Myself, Suyog Khose. Currently, I am a research scholar at Agriculture and Food Engineering Department of IIT Kharagpur. Today's my topic is alternate wetting and drying water saving technology for rice cultivation. Before starting, we firstly introduce about the rice and its importance in daily life. Rice is a staple food for a large part of the population, and it's affordable to every person. Then rice is the excellent source of various essential nutrients, which is important for our good health. Then rice, another feature of rice is the rice can be stored for a long time without getting spoiled. And this feature of the rice is helpful to stock the rice in case of emergency and natural disasters case. Then rice production and trade, which supports the livelihood of the farmers, traders, and food processors. Then we talk about the water requirement for rice crop. Rice is a water intensive crops, and we all know that the rice requires a continuous ponding water depth. So this continuous ponding water depth takes nearly 1500 to 3000 millimeters of water per hectare for one season of rice crop. And this amount required water amount may vary with the climate, then soil types and irrigation methods used for the irrigation. Then it's may vary upon the variety of the rice. Then when we apply excessive water, or when we apply less water, it may affect directly to the production, then yield of rice crop, then nutrients, leaching, water logging. These are the effects of the applying less water or more water. Then from this, we can say that the water management in rice crop is very essential. So the next is the need of water saving technology. As we all know, the water scarcity is the main problem in most of the parts of the world, and agriculture is the biggest user. That means as compared to other industry, you can say, then other civil living would. In all comparison, agriculture is the biggest source of biggest user of the water resources. And another thing, the climate change. The nowadays you can see that there is high frequency and intensity of hydroclimatic extremes such as the droughts and floods, which also affects on the water availability and requirement. Then from this point of view, there is need to apply some water saving technology for the cultivation of rice, as the rice requires highest amount of the water for its growth. Then this water saving technology may help to reduce the water pollution, then agricultural runoff, and finally reduce the carbon footprint which is associated with the rice cultivation. Now we can see one by one different water saving technologies existing. Firstly, alternate wetting and drying. In this session, we are going to deal with this alternate wetting and drying. Here, I just introduce about the alternate wetting and drying. In here in figure we can see alternate wetting, and second is say the drying regime. So in this method, the periodically drying and reflooding is done, and this method reduces water use up to 30%, but which this method maintains or may sometimes improve the crop yield, that means rice yield. Then second one is the system of rice intensification, mostly called as the SRI. In this method, there is an increase in rice yield while the reduces the water use as well as seed and fertilizer inputs. That means we are going to apply less amount of the water, seed, and fertilizer, but in that case also it may increase the rice yield. In this method, the planting population is less, and the seedling which is transplanted, which is at the younger, that means less than 10 to 15 days seedlings is transplanted. Then third one is the direct seeded rice. In direct seeded rice, the rice is directly placed into the dry soil instead of making the seedling, and after seedling then transplanting. Here directly the rice seed is placed in the soil as like different feet, we can say, then groundnut, like that. This method may reduce the water up to 50%, but in this case there may be chances of the reduce the yield. Then drip irrigation, as we all know, which is the pressurized irrigation system. Nowadays, the drip also used for the rice cultivation. Here the drip directly applies the water into the root of the rice crops, rice plants, and which reduce the water uses up to the 40%. Then fifth one is the sprinkler irrigation. As we all know, the sprinkler irrigation. Sprinkler delivers the water to the rice field through the network of pipes. Is called as the laterals, and which applies the water over the rice crops. This may reduce the water uses up to the 30% as compared to the traditional. That traditional means the continuously ponding water, 2 to 5 centimeter depth is maintained in the traditional way. Then let's see in detail about the alternate wetting and drying irrigation practice. Alternate wetting and drying irrigation practice is used from long time, but the new form, that modern form of alternate wetting and drying, AWD, was firstly introduced by the ERI. ERI is the International Rice Research Institute, which is located at the Philippines. In 1990, they developed the modern form of the AWD, and the scientist of AWD, scientist of the ERI, they found that this AWD techniques may reduce the water uses without reduction in the rice yield. So from after that, the AWD has gained the interest. That means farmers can apply this method from 1990s, and this is the water saving technology as well as which reduce the greenhouse gas emission from the rice cultivation. Here you can see these are the two pipes which are useful for the implementing the alternate wetting and drying techniques. So we can see in detail later slides. Here in alternate wetting and drying, the periodical cycle of drying and reflooding the rice is continuously going on. Then this AWD is nowadays applied in various countries around the world. And in 2015, Food and Agriculture Organization, which is the organization of the United Nations, they recognize the AWD as a climate smart agriculture practice for the cultivation of the rice, and which help for the reducing the greenhouse gas emissions. So now we can see the implementation of the AWD techniques. When we are going to apply the AWD, the field should be the completely level and properly drained for the preventing the waterlogging condition, or ensuring that the when we apply the water, it should be continuously uniformly distributed throughout the plot. Then here you can see the pipe. This pipe is called as field water tube, or generally in India mostly known for the pani pipe, which is developed by IRI, that International Rice Research Institute. This pipe is made up of PVC, or maybe local farmers can use the bamboo pipes for making this pani pipe, which has the diameter of nearly 15 centimeter and length of 30 centimeter. Out of this 15 centimeter depth has made some perforations of these holes of nearly 1 centimeter diameter, and the distance between two perforations is nearly 1 to 5 centimeter. And when we are install this pani pipe, there some envelope material is applied around these perforations to avoid the clogging and free working of the this pani pipe. This pani pipe is generally used for the measure the water level inside the in the field, so we can monitor the depth of the water below the surface also. This pani pipe is installed in the field when the field is completely leveled. At the time of installation, there may be 20 centimeter a hole is digged in the level ground, and then this 20 centimeter hole is filled with the coarse sand of 5 centimeter bottom. Then the this perforated pipe covered with the envelope material is placed, and then the sludge is placed around the this pipe to install the pani pipe. And when the installation is completed, the water level inside and the inside the pipe and the outside the pipe is should be equal, so that we can say that the pipe installation of the pipe is successful. Then in this AWD case, the irrigation is applied to the up to 5 centimeter depth when the water level inside the pipe is goes below the threshold, maybe threshold sometimes fixed as a 10 centimeter, 15 centimeter. Here in this figure, you can see that this is the drying regime, AWD, alternate wetting and drying. This is the drying regime. Here the water depth in the pipe is goes below the 15 centimeter of depth, and after this 15 centimeter depth, then the rice field is irrigated to the 5 centimeter of ponding depth. Okay. Then this alternate wetting and drying practice is applied in the field when the rice age of the rice plant or crop is from 10 to 15 DAT. DAT is nothing but the day after transplantation. That means after transplanting, 15 days after transplantation, the AWD practice should be start, and it should be end at the 60 to 70 DAT. That means the panicle initiation stage. That means during the rest of the period, that means starting 0 to 15, 10 to 15, or may sometime it takes up to 20 days. And after the 60 to 70 days, that means at the maturity stage, the water, the continuous ponding water should be maintained in the field. So at the initial stage, that is 10 to 15 days, this initial stage, the ponding water depth is maintained to sustain the crop, and at last the maturity level, the ponding water is maintained for the completely fill and to increase the production, we can say. Then in addition to this, there are some splitting of the fertilizers some farmers makes. So this fertilizer, that means mostly the urea, will be applied in between the season. So this urea is applied during the wetting stage. That means when the field is irrigated to the 5 centimeter depth, that case the urea or that fertilizer application will be done. Then nowadays you all aware with the IoT. IoT is nothing but the Internet of Things, which are some sensors or advanced techniques which is applied in the agriculture, and these techniques applied in the agriculture is helpful to increase the production or easy management of the our field. So this IoT may be applied in the alternate wetting and drying techniques. In here we can see different sensors or different techniques of IoT will be applied in the AWD farms. Firstly, the automated water level control. That means the water depth in the pipe, pani pipe, will be monitored using the automated sensors, which may be ultrasonic sensor, depth sensor, and which is helpful to get idea about the depth of the water inside the pipe. Then soil moisture sensor. These soil moisture sensors may be helpful for the monitor the soil moisture levels and provide the real-time data of the soil condition. Then remotely monitoring and the management. These IoT devices can be used for the remotely monitor and manage the AWD systems, which provide the farmers with the real-time data and alert about the water level or soil moisture. Based on that, the farmer can irrigate the field. Then data analytics. That means the data collected from these sensors, which may be analyzed using different machine learning algorithms, which is helpful to identify the pattern and optimize the AWD conditions. Then integration with the other IoT technologies. Other IoT technologies may be some weather sensors. That means different temperature sensor, humidity sensor, the soil temperature, soil moisture, and PHEC like sensors. Then satellite imagery and different automated irrigation systems. Integration of this will helpful to optimize the water uses and improve the crop yield in these alternate wetting and drying techniques. Then now we can see the advantages of this alternate wetting and drying techniques. There are various advantages. Firstly, the water saving, which may save the water up to the 30% as compared to the traditional way, that is continuously ponding the rice field. And the main focus of this AWD is to water saving, and it saves up to the 30% of water. Then another important advantage of this method is the reduce the greenhouse gas emissions. Mainly the greenhouse that means the methane gas emission, which reduce up to the 50%. And we all know the methane is the important greenhouse gas that contributes for the climate change and finally the global warming conditions. Then improve the soil health. This alternate wetting and drying regime will reduce the soil compaction and promote the root growth. And as the root growth increases, so it directly indirectly affecting on the yield as well. Then cost saving. This AWD techniques can reduce the cost associated with the water pumping, then irrigation, as well as the labor cost which is applied for the irrigation. Because in conventional method, we have to continuously irrigate. So the requirement of the labor pump charges are more as compared to the AWD. So the AWD can save these costs. Then using these techniques, there may be a chance to improve the rice yield and quality as well. Then this technique, it can be easily adopted by the local farmers because of its easy implementation and management. Then the disadvantage of this technique is it may increase the labor requirement. Earlier you can say the labor required for the irrigation may be reduced, but for the implementation, that means the completely level, then this implementation of the pani pipe, then monitor, it may increase the labor cost sometimes. Then there is the potential of the weed growth, as there is continuously wetting and drying condition. So in drying cycle, there may be a chance to growth of the weed. So it may again increase the cost of weeding. Then there is need to specialize equipment. That means we can say the pani pipe. Then for automatically monitoring, we require some sensors. This may increase the cost of the equipments as well. Then this method depends on the weather conditions. We can say in monsoon season, it's not easy to maintain the drying cycle because the continuously rainy season, which made the field is continuously waiting, and in that case the drying cycle will not be managed. So this AW management of this AWD is depends on the weather conditions. Then may some soils in some soils applying the AWD condition will reduce the rice yield. Then we have seen the different advantages, disadvantages of the alternate wetting and drying techniques for the rice cultivation. Let's see what is the future of alternate wetting and drying. Is there any scope in the research or all aspects for the alternate wetting and drying techniques? There is a scope to expansion. That means the implementation of the AWD techniques. The AWD has successfully implemented in various countries, but there is still some countries which are water scarcity and the climate change. Here, this climate change and the water scarcity is focusing or pressing more issues in that region. The AW techniques for rice cultivation may be applied. That means there is a chance to expand the AWD application region. Then there may be integration of some digital technologies, as earlier I have mentioned that the IoT implementation in the AWD. So we can apply some different sensors or AI/ML techniques or some precision agriculture techniques to further improve the effectiveness of the AWD management, as well as the optimize the efficiency. Then there may be a chance to develop new AWD varieties. That means new rice varieties which can be adapted to for different AWD conditions, such as the drought tolerance varieties or varieties with improved nitrogen use efficiency. Drought tolerance varieties, because of the in drying region there may be reduce some yield in drying stage. That means the crop may be the condition of the crop may be decreases, or we can say maybe lowered in the drying region. But some drought tolerance variety can be maintained in wetting as well as the drying stages. Then scaling up the AWD. Government should be it is important, but the government or the policy maker should be focused on to how to this AWD technique can be applied in different region. For this, they may provide farmers to access to finance, technology, and extension services. Then research and development in this AWD technique. The research could be focused on the optimizing the duration and frequency of the flooding and drying cycles, and they may develop new AWD management practices. Here I have mentioned the AWD techniques up to the 15 centimeter, 15 centimeter. But in IIT Kharagpur now we are trying to focus the depth of the water up to 30 centimeter. That means we have different treatments. First treatment is up to the 10 centimeter, 15 centimeter, then 30 centimeter below the ground surface. So we are trying to test the its effects on the rice yield. So this all about the alternate wetting and drying. Here are some articles which I have published in different newspapers and the magazines. This is the information about me. So thank you.
Thank you very much, sir, for a wonderful presentation. I will take up the questions from the participants now.
Yes, sure.
Sir, can you please stop sharing the screen, sir, so that we can see your full video?
Yes, yes.
Okay. The first question is, what will be the approximate minimum cost for installing this technology in an acre of land?
1 acre of land.
Yeah.
Okay. Generally, the rice plots are not big plots, that means up to the acres, but in some cases there may be large plots. But it's general recommendation that for 5 hours we can install one this pani pipe, and the cost of it's nearly 150 to 200 rupees for one pani pipe, because its length is 30 centimeter only, so it's not that much costly. But for 1 acre there may be 7 to 8 pani pipes should be installed. So the we can say 8 into 2, that means 2,000 or maximum 3,000 per acre cost it may be.
Okay. And the next question is, are traditional farmers aware and practicing this technology of alternate wetting and drying?
No, nowadays it started from last decade, but not all peoples, but some peoples are followed this technology in Andhra as well as in West Bengal also. Some people are now aware of this alternate wetting and drying, and they are implementing these techniques in their fields.
Okay, some training is required for them, sir, to start.
No, there is no special training required. But the thing is that they need to follow some techniques. That means the plot should be the completely level, and the installation of this pipe should be the perfect, so that the ponding water level inside and the outside the pipe should be the equal. So these are some points. There may be no need of special techniques, but these are some points they follow. Then it's easy to implement and in the field.
Okay. And like if anybody requires information related to this, if they get in touch with you, you will help them, sir, in guiding.
Yes, sure.
Okay. Sir, according to you, what is the major disadvantage or problem of this technology of alternate wetting and drying?
There may some soil types in which may the what you can say the water alternate water wetting and drying, it may reduce the yield in some soil. And the another thing is that if the soil type is not that means we can say they're not homogeneous throughout the plots, it's difficult to maintain the wetting and drying regime. So the implementation of AWD is not successful in these cases.
Okay. Sir, can you please tell us about yourself, your education, career background, and what made you take an interest in this particular topic?
Yeah. I'm pursuing my PhD here in IIT Kharagpur, and I think I have earlier one delivered session on unmanned aerial vehicle as well. Uh, I'm working with unmanned aerial drones for rice management. Here, in this rice management, I have applied some different irrigation treatments, nitrogen treatments. So at that time, when I'm trying to this rice transplantation, the major issue is the water scarcity. So I have to try to search different techniques which can save the water for rice cultivation. So the review after reviewing so much techniques and all these things, I have found that alternate wetting and drying treatment is easy to implement, and which reduces the water use, but it maintains the rice yield. So it may be useful to rice cultivation, and farmers can easily implement these techniques. So this way, I'm started with the working with AWD, and now I have done 3 seasons AWD practices, and I have found that there will be reducing the water uses up to the 28 to 35%, but there will be no decrease in the yield. And one case I have found that there will be increase in rice yield as compared to the conventional treatment. So this AWD technique can be useful for farmers.
Okay, thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Mr. Khose, Suyog, Balasaheb for the talk and for answering the questions. I like to also thank all the participants in the meeting. This meeting will now be closed.
Yeah, thank you.
You're welcome, sir.